All right, so number 1, chlorine dioxide. 2, sodium chloride. 3, it would just be 1 copper, and then you're gonna need 2 acetates to balance out the +2 of the copper. And then methane is CH4. Okay. All right, so moving to what we call word and skeleton equations. So a little kind of notation stuff, and a lot of what's on this slide you already know for the most part. So looking here, there are 3 parts to a chemical formula. There is the coefficient. So the coefficient will go out front, and that's going to tell you the number of that molecule. That is something we haven't talked about. The idea of the coefficient would be like, if I'm going to make a sandwich, let's say I'm going to write the chemical formula for a sandwich. Okay, here's my chemical formula for a sandwich. My product that I make in my chemical formula. Is there a W in sandwich? Is it W? Is it like this? Is there no? There's no H?
It's not the first day.
So it's like that?
Not 2 C's.
Not 2 C's, okay. Is it, so it's like, I'm just kidding. I'm not that bad at spelling. Okay, sandwich. So you're like, sandwich, what do I need for a sandwich?
2 pieces.
You need bread. Now, somebody said 2. Adam, was that you? Trevor? 2. So the coefficient, the idea of the coefficient tells you how many of that thing you would need. So you're doing a chemical reaction, it would be the idea of like proportions. For every 1 sandwich I want to make, I need 2 pieces of bread. And then I'll let you fill in whatever you need. Say, okay, what if you put meat on there? Maybe you put 3 slices of meat. Whatever, you fill in but the point of this is coefficients are just the numbers you would put in front for whatever 1 thing you're going to make. That's the basic idea of it. Inside you'll use parentheses here if you're going to have a coefficient. That's what they have here. Molecules, what's on the inside. And then the subscript, that's, you should be familiar with the subscript. For naming, that's just saying, for that molecule, how many atoms would that make up that molecule? So for sodium oxide, you'd have 2 oxygens for every 1 sodium. There you go. So, any questions about this? All right, so then looking more specifically at a chemical equation. And my hope is that this is something to review from 8th grade for you. You have the arrow. This arrow, think of the arrow means yields in chemistry. Yields means produces, would be maybe a simpler way. Produces, it's what are you going to make? And then on the right side of the arrow are the products. So the products is what you make. You can think of the arrow sort of like an equal sign. And then the reactants are what you're using. So what you use. Okay? So in this case, what we're making is sodium chloride, table salt. To make table salt, what you use is sodium plus chlorine. Okay? Now, let's say like this happens to be a 1, like there's only 1s involved, but you could have like some numbers in front where maybe you need 2 sodiums for every 1 chlorine. Now that isn't the case here because of the ionic naming and stuff. It all balances out, but you could have like the coefficients in front. But I'll show you some examples of that later on. All right, so moving on from that, are states of matter. So this is something that might be a little more new to you, but I'm hoping that they talked about this in 8th grade for you. They theoretically should have. You got to appreciate that there are states of matter, right? Solid, liquid, gas. Last class we talked about solutions, solutes, solvents, and solutions. So a solution is something that's dissolved in water. So if I have hydrogen exists in the form of a gas, just You know, if it's just existing at room temperature, there isn't some weird pressure going on, it's in the gaseous form. So to tell everybody that, you put parentheses and a G. Same with oxygen. Oxygen exists as a gas, so you put parentheses G. But in this chemical reaction, when you combine hydrogen gas with oxygen gas, you create liquid water. Notice how I said liquid water, because water could be a solid, like an ice cube. It could be a liquid in this case, or it could be water vapor, where it's the gas form. So that's where, like, especially here, that's where the states of matter is very important to indicate, so you know what you're making, or you know what you're going to grab. Aqueous is another one that's not up here. Aqueous means dissolved in water. Okay. So, for example, when we did the flame lab, we were using solutions of metals. In other words, those popsicle sticks were soaked in metals that I dissolved in water. There were solutions of metals. I didn't literally rub metal on your popsicle sticks. I dissolved it. Again dissolved it in water, and we call that a solution. Water is the solvent. The metal is the solute. What got dissolved? All right, questions about this? Notice the coefficients here. So you need, just like you're making a sandwich, you need 2 hydrogens for every 1 oxygen, and you will end up making 2 waters. We're going to do something called balancing reactions, where you'll kind of learn how you know there's a 2 and a 2 there. I'll explain that later on in this unit. All right, so getting into what you're doing today, word and skeleton equations. We're just going to work a few practice problems, and I think after a while you'll hopefully get the hang of it. So a few points to that you will need to memorize. And a lot of these points are kind of common sense, and it's stuff we've talked about earlier. Metals and ionic compounds are solids at room temperature. Breaking news, metals are solid at room temperature. That should make sense to you, right? You don't see metals being gases at room temperature. Now, maybe the idea of ionic compounds being solids at room temperature, that may not be as obvious to you, but that last lab, you were working with 3 ionic compounds. You had sodium bicarbonate, you had ammonium chloride, and you had calcium chloride. Thank you. We call those salts. All those were these white powdery looking things. That's because they're ionic compounds and they're solids at room temperature. All right, so what you do, in the last 2, hydrogen, oxygen, nitrogen, carbon dioxide, those are all gases. So carbon dioxide, and all those, that should make some sense to you, right? When you think of breathing in oxygen, you think of yourself breathing in a gas, not liquid oxygen or something weird like that. And then the last one, water. Water is liquid, but it will exist as a vapor at high temperatures. In other words, if they don't say anything about water, you just assume it's a liquid, unless they specify that it's at some temperature. Now, what high temperature would make water a vapor? What temperature in Celsius would water boil? It's actually the standard for how they set up the Celsius system. If you know that. 100 degrees Celsius. Water boils at 100 degrees Celsius. What temperature does water freeze at then?
0.
Dorian? 0. As soon as you go below 0. That's the purpose of the Celsius system, right? Because we work with water so much. You made anything below 0, that's when water freezes. Anything above 100, that's when it starts to become a vapor. So, there you go. All right, so looking at the word equation, they're telling us solid iron reacts with oxygen to form iron 3 oxide. Okay? So, for all of these, you're going to have an arrow. That arrow is the yields. So what you need to identify, and let me get some different colors here, you need to identify what are your reactants and what are your products. What are you reacting and what are you producing? So let's do reactants first. What would be our reactants here? Heather, what was that?
Iron and oxygen.
Yes, solid iron reacts, so look for that buzzword, reacts with oxygen. So what you're going to write in words, those reactants, so you would write iron. Whenever you're writing the word equation, you don't need to include the states of matter. You would just say iron, and then you use the plus symbol, plus oxygen, yields or produces, then your products. So this one is easy because there's just one product. And if you get the reactants right, the products are just whatever are left over. So to form, that's kind of a buzzword for a product, iron 3 oxide. Remember, if you're doing the formative, just write it all one word. Like that, it just makes the answer key a little bit easier. So on your formative, what I give you is like, I basically give you like a little like question marker there, question marker there, question marker there. Okay. Now then, the skeleton equation, this is the chemical formula. So this is why you need to understand how to name. Because iron, what would be the chemical equation for iron? Fe. Iron is just an element. But then this is where students start to get like, I don't think confused is the right word. They're just going too fast and they forget to do this. You have to include the state of matter. So it is solid iron. So you would put parentheses S. Okay? Because again, back to the flame lab, there could be, I could put AQ there, aqueous iron. That would mean iron dissolved in water. Here it is just a bar of iron that you're reacting with oxygen. Now, what state of matter would oxygen be in? A gas, right? You assume that. So it's one of those gases you would just have to memorize. That's just going to be in the gaseous form. Okay? And then yield, get your yield arrow in there. And then you're going to produce iron 3 oxide. So this is where you got to really know the naming, right? Iron 3 oxide. What will be my chemical formula for that? Iron's Fe. The 3, what do we do with the Roman numeral 3?
Charge.
That's a charge, right? Not the number of iron. So that's telling us iron has a +3 charge. Oxide, that's oxygen. So O, what charge does oxygen have? -2. Charge has got to go to 0. So what combinations in Fe's and O's would you need to get to 0? Yeah, remember the shortcut is you cross them. Whatever the charge is here, it's a -2 there, you would need 2 irons. Whatever the charge is on the iron, that's how many oxygens you would need. So you'd say Fe2O3. Am I done yet? You need the states of matter. Right, so what state of matter would this be in? Geez, how would you know? Conundrum. First bullet point, ionic compounds are solids. This is an ionic compound. Metal, non-metal. So this would be a solid. Okay, unless somebody says otherwise, you assume that's a solid. And yeah, I know this is down a little bit, but the next slides, it'll be pushed up a little bit more. So just because I have these bullet points up here. Okay. Any questions about this? That's what you're doing all day today. We're going to go through a few more samples, but that's the basic idea. You got to be able to read an equation just like kind of said in words, and then break it down into reactants and products, and then write the chemical formulas from those reactants and products. So doing another one, telling us methane gas burns in oxygen to produce carbon dioxide gas and liquid water in a combustion reaction. Okay? We'll talk about the different kinds of reactions. You don't need to worry. Combustion is just referring to like when you combine something with oxygen. We'll talk about that later. But breaking down our word equation, what are our reactants? What are we reacting together? Methane and oxygen. Good. Methane, oxygen. Now, some of you are going to get a little clever and you're like, oh, they always have the reactants first and the products second. That is not always true. Sometimes they say it the other way. Kind of like if you ever like reworded an English sentence, you could like, I don't know the parts of sentences, but like, you know, those different parts of sentences, you can like switch them around, you know? English stuff. All right, now what are your products? Yeah, carbon dioxide and water. All right, so then let's write those down. So you got methane. So word equation, the hard part would just be identifying what they are. So methane and oxygen. Those are our reactants, and then you'll get your yield arrow. That's going to yield, that's going to produce in our products carbon dioxide. Plus water. All right, then the skeleton equation is the chemical formula for each of those. So what is the chemical equation for methane? CH4, good. That's one of those you got to memorize. Chemical formula for oxygen. O2, right? Have no fear of ice cold beer. I have no brighter, clever friends. Your diatomic elements. That's why you had to memorize the diatomic ones. Oxygen exists diatomically with 2. Okay, then you get your yield arrow. And then let's write our products down. Chemical formula for carbon dioxide. One should be pretty easy. Carbon, C. You see di, it's covalent. O2. Now I was going to, what error have I made so far?
You just add the.
I add the states of matter. Even I make the, like, you gotta have them in there. So what state of matter would methane be? Gas, right? Okay. So you gotta add the G. Oxygen. I think they don't say it's a gas, but that's one of those you have to memorize. Oxygen's a gas. CO2, they tell us it's a gas. Had they not told you it's a gas, because they don't always, you assume carbon dioxide's a gas. Also, just think of like climate change and stuff, right? Like carbon dioxide's going in the atmosphere. Plus water. Goodness, I hope you know what water is at this point in your life. H2O. And they tell us it's liquid water, so you got to use the lowercase l. If you wanted to put like a capital L, just to be clear, you could. It's technically a lowercase l. On the formative is not case sensitive, so it doesn't really matter if you do capital or lowercase. Okay. And on the formative, it doesn't matter if you have a space there or not. I put both answer choices in there. All right, so there you go. Any questions about this one? I think I have like one more.
Yeah.
One more. All right, let's do one more, and then you'll have time to do the formative. Yeah.
Instead of first one we did, the iron oxide, that was like one, like, element, right? That's why we just do like iron plus oxygen.
This one right here?
Yeah, so like the final product was just like one formula,
Yes, yeah.
but then for this one, we keep the plus because they're like separate. You want me to-
Oh, you're saying here we had one product, but then here there's 2 products? Yeah. So because some reactions you make just one product. Other reactions you'll make 2, sometimes 3 products. And so you'll need a plus sign after each product. On the formative, I didn't include a plus sign. It just made it more complicated for me to like Photoshop that in there or whatever. But yeah, if you're handwriting it, you have a plus sign between each individual reactant or product. Okay. All right, let's do the last one. Solid zinc carbonate breaks down to form solid zinc oxide and carbon dioxide gas. So what would be my reactant here? Or reactants? Ooh, not solid zinc oxide. It'd be zinc carbonate, breaks down. So in this case, you're only going to have one reactant. That's going to be your zinc carbonate. So zinc carbonate is going to break down. So it's going to break down to form. My products, it would be zinc oxide and carbon dioxide. So we'd write those down. Zinc oxide plus carbon dioxide. All right, and then our skeleton equation, what would be the chemical formula for zinc carbonate? Zinc is Zn. Carbonate's one of your polyatomic ions. CO3. Let's check our charges. Zinc is an exception to the transition metals. It's always a +2 charge. Carbonate's a -2. So because those charges go to 0 for you, you actually just can leave it like that. And then that's our only reactant. Oh, state of matter. Zinc carbonate, they tell us here it's a solid. Technically, they wouldn't need to tell you that. If they didn't say anything, you would assume it's a solid because it's an ionic compound. Zinc oxide, let's get our chemical formula for that. So zinc is Zn. Oxygen's O. Zinc's a +2. Oxygen's a -2. So they gave you another easy one. That goes to 0, so we're good there. Just Zn and O. Add your state of matter. The solid. They tell you that, but again, if they didn't, you would assume it's solid because that's an ionic compound. And then plus carbon dioxide, which we've done earlier, that's CO2, and they tell you it's a gas. But again, if they hadn't said it's a gas, you could know that because that's one of those you just have to memorize. Just kind of got to understand at this point. Any questions about that? And I think that's last. I included the naming slides if you needed some refreshers on the naming stuff. But there you go.